A typical AI agent then simply communicates with a chosen LLM API endpoint by making requests to centralized cloud infrastructure that hosts these models. LLM API endpoints are specifically designed to serve a large volume of diverse requests using one generalist large language model. This operational mode is deeply ingrained in the industry. In fact, it forms the foundation of a substantial capital investment in the hosting cloud infrastructure, estimated at USD 57 billion. It is anticipated that this operational model will remain the cornerstone of the industry and it is anticipated that this operational model will remain the cornerstone of the industry and that large initial investment will deliver returns comparable to traditional software and internet solutions within 3 to 4 years. In this work, we recognize the dominance of the standard operational model, but verbally challenge one of its aspects, namely the custom that agents' requests to access language intelligence are, in spite of their comparative simplicity, handled by singleton choices of generalist LLMs. We state in section 2, argue in section 3, and defend in section 4 the position that small, rather large language models are the future of agentic AI. We, however, recognize the business commitment and the now legacy praxis that is the cause for the contrary state of the present. We discussed in section 5. In Remedy, we provide an outline of a conversion algorithm for the migration of agentic applications from large language models to small language models, section 6, and call for a wider discussion in section 7. If needed, we concretize our stance. We attach a set of short case studies estimating the potential extent from LLM to SLM replacement in selected popular open source agents. Coming on to the section 2, position. 2.1, definitions. For the purpose of concretizing our position, we use the following working definition. Working definition 1. SLM, small language model, is a language model that can fit onto a consumer electronic device and perform inference with latency sufficiently low to be practical while serving the agentic request of one user. Working definition 2, an large language model, an LLM, is a language model that is not a SLM. We justify the wordings of this definition in section A, but note that their choices has little bearing on the essence of our position. We note that as of 2025, we would be comfortable with considering most models below 10 billion parameters in size to be SLMs. We use the words agent and agentic system interchangeably, preferring the former when emphasizing the software with some agency as a whole, for example, as seen in popular coding agents, and the latter when highlighting the system's aspect of the agentic application as a sum of its components. For example, not all LMs of an agentic system are replaceable by SLMs. For brevity, we focus on LMs as the bedrock of agentic applications and do not explicitly consider vision language models, although we note that our position and most of our arguments readily extend to vision language models as well. Coming on to section 2.2, statement. We contend that SLMs are V1 principally powerful sufficiently powerful to handle language models errands of agentic applications. V2 inherently more operationally suitable for use in agentic systems than LLMs. V3 necessarily more economical for the vast majority of LMs uses in the agentic systems than their general purpose LLM counterparts by virtue of their smaller size. And that on the basis of use, V1 to V3 SLMs are the future of agentic AI. The phrasing of our position is deliberate. In its statement, we wish to convey that the described future development is ultimately a necessary consequence of the differences between SLMs and LLMs if the natural priorities are followed. We do not make a recommendation or try to impose an obligation. We make a statement of what we see as a faithful reflection of community's values in this context. Section 2.3 Elaboration. We assert that the dominance of large language models in the design of AI agents is both excessive and misaligned with the functional demands of most agentic use cases. While LLMs offer impressive generality and conversational fluency, the majority of agentic subsystems in developed agentic systems are repetitive, scoped, and non conventional, calling for models that are efficient, predictable, and inexpensive.